This is Honors Algebra 2 Pre-Calculus. We are in 9.7 of Pre-Calc and we're doing probability. Example 9, you draw 3 cards with replacement, and we'll talk about why that with replacement is important in a sec. What is the probability that all 3 are face cards? So because I'm replacing this card after I draw it, these are independent events. If I were not replacing the card, then they would not be independent, because if I don't replace the card, then I am affecting the probability of the next draw by not putting the card back, right? So, for instance, if I want the probability of drawing a face card, if I'm not putting the card back and I draw a face card on the first pull, that now lowers the number of face cards in the deck for the next draw. That's why this with replacement is important. So, essentially, the probability that they are all face cards is going to be the probability that the first one's a face card times the probability that the second one's a face card, times the probability that the third one's a face card, right? So there are 3 face cards, king, queen, and jack, in each suit, so that means there are 12 in the deck. So the probability I draw a face card at the beginning is a 12 over 52. I then put my card back, so the probability I draw a second card that's a face card is still a 12 over 52, and the probability I draw a third card that's a face card is still a 12 over 52. All 3 of these are independent events. I would suggest that you cancel the 4 just to make your life a little bit easier. So this is 3 13ths times 3 13ths times 3 13ths, which you don't have to do by hand. I don't know 13 cubed off the top of my head, so it's okay if you're like, hey man, that's just not a thing I'm going to do. It is 2,197, so if you do 27 divided by that number, you get that the probability that all of them are face cards is a little bit over 1%. So that's 1.228 or 9%. So it's a pretty slim chance that you get face cards on all 3 times.